And hello guys, I think we can start. I will just demonstrate. I think if you follow the instructions here, as well as I think this also shows in the lab manual, it's pretty straightforward to do. So this, like the instruction, is actually also come from this very good like Nature protocol paper. We just follow this. At the end, they have some session. We just use the instructions from that paper. So if you want to know more detailed information, just go to that paper to read. So essentially what this is doing is that as you may know from like my lecture in week 6, if you can like say building this lateral flow assay, that actually you see with the different concentration, and it actually show the difference like the intensity of color, then you essentially can build a quantitative assay. Okay, the way that it works is again, like what I mentioned in week 6 lecture, is to build this so-called calibration curve, which plot the relationship between a known concentration of analyte and then their response. Okay, so is here if they have a like linear relationship. If you have any sample that have an unknown concentration that based on the Y value of that unknown sample, and then you can get the concentration, that is X value, from the calibration curve. Okay, so in our Hive lab, we will try to build this. We will do different concentration of PSA analyte. And what I want to point out here is actually want to build this like a good assay to actually showing different intensity with different concentration needs a lot of effort in the assay development point of view. So we probably, our Hive lab, if you don't see such like nice change of intensity, that's probably meaning that our assay is not optimized. So that will be a lot of effort in the assay development. Say, for example, how to control, say, the particle concentration in the conjugate pad, and how to control the concentration of the test line antibody, and also like so that you can actually working in the linear range of your calibration curve. So that is needs a lot of assay development. So if you don't see like the color change, like intensity change in your Hive lab, so don't worry about that. You can try to analyze your own data, but to see how it goes, okay? But here, I'm just picking a example image. This one is from this paper. I think it is actually using magnetic like nanoparticle, not gold, but it's still showing very nice like visible change of the gradient of color. So we're just using this image to demonstrate. Okay, so if you actually have the ImageJ software, so then you will probably have this like panel. Okay, so I'm just following that instruction to just demonstrate. So if you download an image, so this is the image that I have downloaded already. So what you will do is actually just drag this image into like ImageJ, and it will show this. So just to explain a little bit this image. It has a control line, okay? But we are going to do the quantitative analysis only for the test line. So don't get confused about the control line, but we just need to read out the intensity from the test line. So from 1 to 8, so it's actually have different concentration, and the concentration is actually listed in here in campus canvas, and also the Hive lab manual. The last part of Hive lab manual is this concentration. So from 1 to 7, So it's changing from this concentration. And the number 8 is actually a blank sample. Okay, so we're not going to use this one, but the blank one is actually tells you like the non-specific binding, and also if you want to get the limit of detection, that is based on the blank sample, as I mentioned in week 6 lecture. Okay, so when you got that, and then the first thing you need to do is go into the image and then into color, and you need to split channel. Okay, so because like any color is just the red, green, and blue, so if you split that, it will essentially give you 3 channel and all in black and white. So black and white, a gray color, but it's split into like red, green, and blue. Okay. And according to the paper, that the Nature Protocol paper, it mentioned that if we have like the image, like say the gold nanoparticle is red color, so it's better to use green channel for analysis. This is because the green channel will give you the most like sensitive results. So that is what's mentioned in the Nature Protocol. So here we will just use one channel, just use the green channel for get the like the intensity. Okay. So then what you do, so I probably just close this, close red and blue, and then let's come to here. So then what you do, we just here use the way that's showing in the paper. So what is doing is that if you use the line, and then if you draw a line, and then essentially it will get a profile of the intensity. Okay, so I draw a line and then here and go to analysis and then go to plot profile. Yes, so essentially give you this. Yeah. By saying that, this is not only the only way to get quantitative results. There are other paper that actually say just using the whole area, like when we do like Western blotting analysis, getting the whole area intensity. That is also some paper that doing that way. So there are different ways, but here we just demonstrate using the profile way. Okay. So why you see this profile is just from the left to the right. It's actually corresponding to from the top to bottom in the image. So the left peak you see here is actually the control line. So we don't use this one, but what we use is on the right one, the test line. Okay, test line. So essentially we want to get the peak height of this peak. So that means you first need to get like, if I move this cursor, you can see on the here, they're actually showing some number. Okay, if I move around, it gives the X and Y. Okay, if I move it to say the dip of this peak, then it give me some number. And here, I just want to know the Y number. Okay, so if I place the cursor here, then you're showing the Y is 143. And then I think you can start a new Excel file or just using, say, the lab manual, which is a Word document. Okay, so it's actually give you this table, and then you can just put that number in the table. That means the peak, like say for the first picture, the peak intent value of the test line is 143. So you just put here, okay? And then we need, because we're getting the peak height, we essentially need to know the baseline. Yes, so baseline is what we call the background signal. So if you can see from here, this line, this baseline is actually where the background is. So then you need to record here, place the cursor here, like at the baseline, and record what is right here, the Y value 236. Okay, so then that's the number you essentially need to put in here. Yeah, And then you do all for the for the 7 strip. And then the peak height is actually what we show here. Peak intensity is what the background minus the test line. So it's B minus A. So you will essentially get that number, okay? So once you done all of it, then later we show here is how you can build this calibration curve. Next week, when Anthony give the second MATLAB tutorial, he will include this part as well. So at that time, you will have your data, and then we will see how you plot this like linear relationship, and also how you got like this relationship and R value by using MATLAB. I think that is a better way for like scientific presentation, scientific plotting. MATLAB is the better way. But here I will also like showing quickly how you can do that using Excel file, okay? So I've already done here in the Excel, yes. So what I listed here is the peak value of the test line, and then you have the background signal, and then this column is what I think is the this one minus like B column minus A column, and then essentially, if you want to plot, you're actually plotting these two columns. So plotting the relationship between the analyte concentration and also the peak intensity, okay? So the way that you plot this, just move this, is that you're choosing, So you're choosing the data you want to plot, and then you go to insert, and then you go to this one. So this one is for the plotting. We only use the scatter plotting, yeah? So here, plot all the dots in like a scatter plot without any line in there. And you see here, this one and this one, what I plot here is actually quite different. So what is showing is actually this one, the new plotting is showing as a linear relationship within the X value. But for the calibration curve, we actually want to see the axis in log plotting, okay? So the way that you can change this is to just to, I think, double click in the X value and then showing these X axis options. And in here, you just click log scale. Yeah, so then you can see this one is actually plotting axis in a log display. Yeah, and then the way that you actually add in the trend line is you click on the dots instead of the axis, and then right click and then add trend line. Yeah, so add trend line, and then here, because like we are displaying like in log plot, we want to see a linear relationship within the log display. So that is why we just show here, click trend line in log plot. Yeah, and then if you click display equation, and then it display R value. Yeah, so it will just give this. So R value, if it's closer to 1, it means it have a like better fitting, okay? So this is the way that you can quickly check, yes, whether you have a good like plotting or not. Something I noticed here, like comparing here and also this one, is actually this one is this like showing in a log like units, but this one is, I think this unit is not in log, but it's the display is in log. So that's just a different, but essentially it's doing the same thing. I think next week when Anthony explain, he probably using one of this. We will see. I will discuss with him how he want to proceed this. And yeah, so now please just try image analysis and then see whether you can plot in Excel first. And then with that data, the next week in MATLAB, we can then do a proper plotting using MATLAB. Okay?